Okay, I just did this problem. I didn't have the camera on, but I don't want to redo it. So, ta-da, here it is. Actually, number 8 on the test. Almost everybody who chose it got it right, I think. So I'm going to skip number 8. That was straightforward. That was just put it in reduced echelon form of a matrix. Number 9 had an additional wrinkle at the end of it. The number 9 asked us to take this matrix here. Let me write this a little clearer. 3, 2, 1. 3, 2, 1, 1, 0, 1, 4, 3, 2. First, write it in reduced echelon form. So what did I do? Let me see. I switched these rows, and then I subtracted 3 of these from this. They gave me this. And I subtracted 4 of these from this. They gave me this. And then I divided this row by 2 just to make it a little bit nicer. And then I subtracted 3 of these rows away from that and got this. And then I took this row minus this row and this row plus this row, and I got this. So here it is. Now this is the identity matrix, but it's also the prototype or the standard type of matrix where we're in the class of 3 by 3 matrices, and this is the non-singular type. This is the type. Had this been a system of equations, it wasn't, but suppose it was 3 equations and we had some constants on the other side. What this would mean is that there's a unique solution. We weren't asked to talk about that, but okay, fine. Now, what was the additional thing added on to the end of this? The additional thing was show that each row of this reduced matrix is a linear combination of the original rows. So I'll do one, and then you can try the other 2. I just took the first one. It all goes the same way. We want to show that this row right here is a linear combination of these 3. Now, I wrote this in vertical style because, oddly enough, it's easier to think about. But I'm trying to show this row. So where's that row right there? I wrote it here. Is a linear combination of this row, and this row. Well, this determines this system. We've already done that so many times, right? And I solve this. So this is all the usual business of the elimination method. And what did I wind up with? I wound up with C equals 1, B equals 1/2, and A equals 3/2. So that shows it. Now, just to make sure, like double check or whatever you want to call it. The idea is that if you there's a 3/2 in there, 1/2 in there, -1 in there, multiply that out, you should get that. Well, you can do this here, and it actually does. Like the first half, 3/2 times 3 is 9/2, plus 1/2 is 10/2. That's 5 minus 4 is 1. Check. Here, I'll just do it right now. 3/2 times 2 is 3 plus 0 minus 3 is 0. Check. And 3/2 times 1 is 1/2, plus 1/2 is 4/2, which is 2, and 2 minus 2 is 0. Check. I'm going to do number 10 in class. So there's the test. And again, I hope you're starting to read through chapter 2 because I want to try to move through chapter 2 quite a bit quicker than we did chapter 1. Okay. See you Tuesday.